Hello dear students, my name is Swamy, working as an assistant professor in Marri Laxman Institute of Technology and Management. Today our topic is energy sources. So from in this, now we are going to discussing solid fuels. Before we are going to discussing about the solid fuels, mainly the fuels are classified based on the source, two types, that is natural fuels and second one is artificial fuels. Again this classification, again it is going to be classified into three categories based on the physical state of the fuels. They are solid fuels, liquid fuels and gaseous fuels. So apart from this classification of the fuels, now we are going to discussing about this solid fuels. So solid fuels are nothing but the fuels which are in the form of solid states. Such type of fuels called as solid fuels. So the main occurrence of the solid fuels are due to the environmental hazards. The trees, the plant materials were buried inside the earth. Inside the earth, in the presence of temperature, in the presence of pressure, in the presence of some bacterial actions, these plant materials over a period of thousands of years, slowly the plant material is going to be converted into a brown black solid materials. That brown black solid material will be called as coal. So coal is the best example of solid fuel. Wood is also example for the solid fuels. Now here example for this coal and coke and as well as wood. So these are the best example for the solid fuels. Now we are going to discussing about the formation of a coal. Generally the coal is the best example for the solid fuel. So it is a carbonous matter which is produced by the decomposition of a vegetable matter and animal matter which is buried inside the earth due to some environmental hazards, due to some earthquakes. So all these plant materials are buried inside the earth, and due to the presence of some high temperature inside earth and due to some bacterial actions, due to some pressure, so this plant material is slowly going to be converted into a black color compounds. That black color compound will be called as coal. This is the formation of a coal from the wood materials for the formation of a coal. So initially the wood material is slowly converted into peat, and peat is converted into lignites, and lignite is converted into bituminous, and the bituminous is converted into anthracites, and anthracite is going to be converted into graphites, and after that formation of a coal. So this is the transformation of a from plant materials to coal. So therefore ranking of coal. So the ranking of coal during the qualification of a wood, the first stage of coal is peat. The first stage of coal is peat. That is the wood materials or the plant materials or animal material is slowly converted into peat, and it is ranked in the lowest among the coals because of The ranking of coal is nothing but depends upon the percentage of the carbon present in the particular components. We can give the ranking of the coal. So in this speed, it doesn't consisting of carbon percentage. That's why we can give the rank is very low. Other coals are lignites, bituminous, and anthracites. So here slowly wood material is slowly converted into peat, and the peat is converted into lignites, and lignite is converted into bituminous, and the bituminous is converted into anthracite, and after anthracites and the graphites will be formed. After graphites, one carbonish compound will be called, that we can call as coal. So this is the transformation from the wood to coal. So when we see the percentage of the carbon from the wood to coal, here the percentage of the carbon is very less in the wood, whereas in the coal, the percentage of carbon is more in the particular coal sample. That's why from the wood to coal, the calorific value gradually increases from wood to coal. So therefore, the calorific value is increases means the calorific value, it depends upon the percentage of carbon. That's why, so from the wood to coal, percentage of the carbon is going to be increases, and simultaneously what happening here, the calorific value is also increases. Next topic, analysis of coal. Analysis of coal. So in order to understand whether the coal sample is good or bad, so we can't judge easily. That is the reason we should analyze the coal sample. So this analysis, it will give the information about the ranking of the particular coal sample, whether the coal is good or bad, or whether the coal is producing the high amount of heat energy or not, whether the coal is having the calorific value is more or not. So based on this, so we can give the grading of the particular coal. So this assessment of the quality, this assessment of the coal, it will give the quality of the coal is carried out by the two types of analysis. The analysis of coal, which is carried out by the two steps. One is the proximate analysis, and second one is the ultimate analysis. So coming to the first one, proximate analysis. This proximate analysis, it will give the information regarding the practical utility of a coal. So that in this analysis, the percentage of the carbon is indirectly determined. So that, and this analysis includes the calculating the percentage of moisture, percentage of volatile, percentage of ash, and after that we can calculate how much percentage of the carbon which is present in the particular coal. So let's see one by one. How can we calculate the percentage of moisture present in the coal? First of all, you should take a known mass of a finely powdered air dried coal is taken in a crucible. So the first one is, you should take a known mass of a finely powdered, the coal, whatever the coal sample you are taking, that should be powdered form. A finely powdered coal sample you should take in the crucible, and after that, that crucible you have to heat it up to 110 degrees centigrade for an hour, and after that should be cooled at normal room temperature in a particular desiccator, so that the moisture which is present in the coal sample is removed as a water vapor, and the process should be repeated. So the weight of the coal is reported and the percentage of the moisture on the basis till a constant weight is obtained. Therefore, The percentage of the moisture we can calculate by using of this formula, that is loss of weight of the coal. The weight of the coal after removal of moisture present in the coal divided by weight of the coal sample you taken before burning, means that the percentage of the moisture is equals to weight of the coal after removal of moisture content present in the coal divided by weight of the coal sample you taken before burning or before combustion into 100. So by using of this formula, we can calculate the percentage of the moisture present in the coal sample. Next one, percentage of volatile matter. So volatile matter, the volatile, what is the meaning of volatile? The volatile is nothing but easily evaporated substance. Now by this analysis, by this proximate analysis, if any volatile component present in the particular coal, we should also find out. So in this, to determine this percentage of volatile present in the coal sample, a dried sample of coal which is left in the crucible in the previous step, which is covered with a cap which is placed in a muffled furnace and maintained at 950 degrees centigrades exactly for the 7 minutes we should heat. And whatever the coal sample you are taking, that coal sample, that powdered form of coal sample should not consisting of moisture. Yes? And after that, the crucible is taken out, then cooled in the air, then in desiccator, and after that you have to weight it. So the loss in weight which is reported but the percentage of volatile matter. Therefore, the percentage of volatile we can calculate by using of this formula, that is loss of weight of the coal after removal of volatile content matter in the particular coal divided by weight of the coal sample you taken before combustion or before burning into 100. Once again I am going to repeating the percentage of volatile matter which is equals to loss of weight of the coal after removal of volatile matter, after removal of volatile substances present in the coal by weight of the coal sample taken before burning or before combustion of the particular coal sample into, we should multiply with the 100, then you will get this percentage of the volatile content present in the coal. So in this way, so we can calculate approximately the how much percentage of the volatile content present in the coal. And the third one, ash contents. And when you will get the ash after complete combustion of the particular coal sample. After complete combustion of the particular coal sample, you will get the ash. So based on this concept, the coal sample you should take, and that should be free from moisture and that should be free from volatile content. So whatever the coal sample you are taking in order to calculate the percentage of ash, so that coal sample should not consisting of moisture and volatile matter. And that coal sample you have to heat it in a crucible at 700 degrees centigrades in the muffled furnace in the presence of air, so that it undergoes complete combustion and results in the formation of ash. So here, to calculate the percentage of ash present in the coal, we should take some precautions. That is, the combustion should be complete. The partial combustion will not get ash. So complete combustion of the particular coal sample only, we will get the ash. So then after, the crucible is taken out and cooled in a normal room temperature in a desiccator, and after that you have to wait. So heating followed by cooling and weighing is repeated to get the constant weight of the residue, that is nothing but ash. So the residue is reported as ash, and therefore the mass of the ash then determine. So that approximately you can calculate that's the percentage of the ash present in the coal sample. That is, so percentage of ash is equals to mass of ash. That is, we can also write here weight of ash formed, weight of ash formed after complete combustion of the coal, weight of ash produced, weight of ash produced after complete combustion of the fuel by weight of the coal sample you taken before combustion or before burning of the coal, and you should multiply it with the 100. Then you will get this ash content present in the coal sample. So my dear students, till now in the proximate analysis, it will give us the information about that. How can we calculate the percentage of moisture, percentage of volatile, and the percentage of ash? And the last one is carbon. So here the carbon, it is the main component present in the coal, that is carbon. So it can be determined by subtracting the sum of the percentage of moisture plus volatile plus ash. The percentage of the carbon we can easily calculate by using of this formula, by the following formula. You have to add percentage of moisture, percentage of volatile matter, and the percentage of ash. After that, you have to subtracting from this 100, and you will get this percentage of the carbon. So in this way, the proximate analysis, by the analysis of coal or by the proximate analysis, we can get the information. It will give us the information about that. So how much percentage of the moisture present in the coal, how much percentage of the volatile present in the coal, and how much percentage of the ash is produced after complete combustion of the coal, and how can we calculate this percentage of carbon theoretically or practically we can determine. So these are the some of the textbooks which are related to this analysis of coal, so that we can easily understand by using of these different textbooks. And thank you so much. And next class we will continue the we have the second type of analysis there, that is ultimate analysis of coal. We can discuss in the next class. Thank you.